Hello everyone, and welcome to today's webcast on Liberating AV Control from Dedicated Hardware. Thanks for coming. This presentation is sponsored by QSC. I'm Cynthia Weishart, editor of Sound and Video Contractor. Today we're going to be discussing how integrators, control programmers, and end users can break from the traditional ties of dedicated AV control hardware and use software-based control as part of an integrated audio, video, and control platform. Today we have a group of AV professionals on the line who will be speaking to you. I'll be introducing them in a minute. First, I'd like to remind everyone to make sure their computer speakers are on. I'd also like to draw your attention to the question feature on the right rail of your screen. If you'll expand that item, you'll be able to ask questions throughout the broadcast. I encourage you to do so. We'll take as many of them as we can at the end. Just type your question in and we'll see it. If you have any technical difficulties during the presentation, you can also use the question box to reach out and our producer will help you. Today on the line, we have the following group of professionals: Martin Barber, the product manager at QSC. Gregg Matson, he's an application engineer at QSC. We're joined by Brian Crist. He's a technical support and application specialist at VoIP, and he's here to talk to us about a case study, an installation at the Chicago Teachers Union. We'll also be hearing from Chris Lloyd, product engineer at Ataro Tech, and we'll be joined by Josh Arnold, also of Ataro Tech, who will be available for your questions at the end. To begin, first off, we have Martin Barber on the line. I'd like to tell you a little bit more about him and then we'll jump right in. Martin joined QSC in 2010. He's currently the product manager for installed systems, where he oversees all audio aspects of the QSC Q-SYS platform. Martin has worked in professional audio for 17 years. He's had engineering positions with manufacturers including BSS and Harman International. He is also an AV systems engineer, and as such, he's designed and installed major projects including Wembley National Stadium and the O2 Arena in the UK, as well as the Atlantis Hotel and Water Theme Park in Dubai. So I believe we're ready to turn over to Martin. I'll be back to you shortly.
That's great. Thank you, Cynthia. So what I'd like to do is to introduce you to the Q-SYS platform, set up a foundation ahead of the rest of the presentations that we're going to be having today. So at QSC, we've recognized that our customers face many common challenges in attempting to build very complex systems which are commonly made from various vendors' products. It's very common today to have audio, video, control endpoints and devices from different vendors, which of course means that they aren't designed from the ground up to work together. And that leads to challenges in both implementation and troubleshooting, but also increased costs in those development of those projects. At QSC, we work very hard to build a completely integrated end-to-end solution for all your audio, video, and control requirements. Q-SYS has been on the market since 2009. In fact, we started development in 2006. And back then, in 2006, we called the product Intervac before it was released. Intervac stands for Integrated Video Audio Control. So what that indicates really is that from its very inception, Q-SYS was always intended to be a fully integrated digital multimedia system. And whilst we focused our initial efforts in the market on the audio aspects, we're now leveraging and unlocking the video and control capabilities of the platform. Just in order to help understand the platform, I want to describe the technology that we use, which is really radically different to everything else on the market. At Q-SYS, in Q-SYS, we're using Intel as the processing engine. So all of our signal processing and control processing happens inside standard Intel chipsets. On that, we're running a robust and purpose-built Linux operating system. So this is a stripped-down, purpose-built, AV-centric Linux distribution that we've customized with real-time extensions, allowing us to do real-time audio, video, and control processing inside that Linux environment. In order to accommodate networked audio-video control throughout the system, we've implemented standards-based network technology using open and accepted IT standards, products, and solutions based on standards from the IEEE, the IETF, the AES, etc. And that allows us to provide real-time, robust audio, video, and control networking over completely standard IT networks. In fact, our networking technology was designed specifically to allow us to integrate directly with standard converged IT networks. So on top of this PC foundation, we have a software layer, which is where we do all of our signal processing and effectively define what the product is. So inside that software layer, we do all of our real-time signal processing, our auto mixing, acoustic echo cancellation, and in addition to our control processing. So what you see is a very, very agile platform whereby we can take this top layer of software and redeploy it on any other hardware platform that is Intel-based and can run Linux. So it's a very different approach to product development inside our industry. And as you can see, it truly is an IT product that's developed for AV professionals. Now, in order to help you understand why we chose Intel as our processing platform, we did some benchmark tests to help illustrate the comparative processing horsepower that we have inside our processing platform versus many other pieces on the market. And I should really illustrate that we have great respect for our competition in this market space. This is not about us trying to illustrate how much better we are. This is really about illustrating why we chose this development path. So we took a very simple, repeatable signal processing chain, and we deployed that inside our platform and copied and pasted it as many times as we could until our signal processor said it had no more DSP power left. And we repeated the exact same process in many other products in this market space using their own software, using the exact same signal processing chain. So the numbers you're about to see represent the numbers of times we could copy and paste that signal processing chain within those products. And what you see is on the left-hand side of the chart, you see very small differences between the capabilities of those products. And what this really illustrates is the fact that they're all based on very much the same technology and topology. All of the products you see on the left-hand side of this chart are based on very similar architecture, which is a purpose-built dedicated hardware device that is using some number of traditional DSP chips. With Q-SYS, we're using Intel instead to do all that signal processing. And what you can see there is the columns in blue illustrate a dramatic difference in the amount of raw horsepower inside our modern computer-based processing platform versus everything else that's on the market today. And the reason for this is it allows us to build features in software that commonly require dedicated hardware for using other platforms. Acoustic echo cancellation is a really good example. AEC is an incredibly CPU-intensive task, and it's very common with other platforms to require a plug-in AEC cards or dedicated AEC processors inside those boxes. What you're seeing is dedicated DSP chips, which are purpose-built only to do echo cancellation on those input channels. And as a result, those inputs are very expensive. With Q-SYS, we have that incredible horsepower to be able to build that AEC processing inside our software environment. So first of all, it doesn't cost any more. And second of all, it's very scalable and very flexible. So when we released AEC processing inside our platform, it came as a software upgrade, which was available immediately at that point and retrospectively upgradable on any Q-SYS core we had shipped from day one back in 2009. And that is a common methodology with our platform. We're working very hard to implement software features where others might require dedicated hardware. Voice over IP is a really good example as well. Very often you have dedicated network interface ports which are dedicated to just voice over IP. With Q-SYS, we build in our soft phones as software components, and you can allocate them to whichever network interface port you require. And in our larger cores, you can have as many as 64 voice over IP endpoints in those system designs. Now, multi-track playback is another example. With the exception of multi-track playback, everything else you see on the screen here is offered free of charge with our software upgrades. Multi-track playback actually affords the ability for customers to replace lots of dedicated external hardware, such as external playback devices. With Q-SYS, the customer can choose if they want to purchase a license whereby they unlock up to 128 tracks of digital media playback from inside the Q-SYS core processor. And this is something that we'll see much more in our future, the ability to allow or add functionality based upon software licensing. With respect to how the Q-SYS system looks like, we have a Q-SYS core processor, which is the audio-video control processing engine that is responsible for the entire solution. That connects over a completely standard IT network to any of our I/O peripheral devices. Those I/O peripheral devices are network-connected audio, video, or control I/O endpoints, and they connect over a completely standard network back to the core. The core actually can be made dual redundant, so if you have a system that must have near zero downtime, then it's very, very simple to add a second core processor. They can be physically co-located if you want, or they can be different sides of a building campus. As long as they're on the same network infrastructure, you can place those cores wherever you need. So if one core is taken off the network, the standby core takes over. And what you'll notice is, for anybody who's got any background in IT, you'll recognize that this is very much a server-client relationship. The core being the server, and the I/O peripheral devices being the clients. So not only is the network technology that we use very IT-friendly, so is the topology that we use to deploy this. So moving on, the Q-SYS platform is fully I/O agnostic, and by that I mean we can interface with the broad range of audio types and sources that you might want to on a modern system design. So analog I/O, of course, is accommodated on our solution, as is digital in the form of AES EBU or AES3. We also offer native networking in the form of QLAN. QLAN, as I described already, is our standards-based technology for connecting any Q-SYS device with the Q-SYS cores. We also offer native AES67 for interoperability with any other system or technology that supports the AES67 interoperability standard, in addition to onboard USB for bidirectional audio. So very, very simple to integrate all those audio types with the platform. We also offer plug-in network interface cards for Dante, CobraNet, or AVB. So as a result, it's very, very simple to integrate Q-SYS with any of these solutions. And in fact, we can run all of these technologies at the exact same time inside a single processor if necessary. From a video perspective, QSC chose with its first video offering to solve some of the common challenges in mid-size or large meeting spaces, where today it's very common in software-based conferencing applications to use either USB or HDMI-based video cameras and bridging endpoints. They all have their benefits, but they also have significant challenges, not least the number of cable types for each of the cameras and also their flexibility. The USB, for example, is great at connecting two devices together, but if you want to take that USB camera and share it simultaneously with multiple PC endpoints, you can't do that. Our solution is to leverage the network in the same way as we do with our audio endpoints. So using network-connected professional conferencing room cameras, we can provide a single cable type to the camera and a single PoE cable to our bridging endpoints and have as many of these cameras and endpoints as we need. We can actually support up to 256 network-connected video cameras and 50 AV to USB bridging devices, all running concurrently on the same solution. So it's a really unique and very flexible solution for in-room video processing for soft codec applications. So that covers the basis foundation of the Q-SYS platform. I'm going to hand back now to Cynthia, who's going to introduce Gregg to talk more about control.
Hi, thanks, Martin. Yes, before I introduce Gregg, I just want to say one thing. I did notice a question coming in about getting this presentation on demand after the fact, and I wanted to remind everyone on the line that you can return to this presentation at any time through the link you already have and view it on demand. And you can also share that link to anyone else, and they can also come in and see the presentation at a later date. All right, so Gregg. Next up, Gregg Matson. He serves as product manager for installed systems at QSC, where he oversees the control aspects of the Q-SYS platform. In this role, Gregg is bringing over 15 years of experience in control programming. Prior to technical services for Crestron, so he knows a little bit about control, where he managed the local engineering team and taught a wide variety of training courses. So Gregg, thanks.
Thanks, Cynthia. So yeah, as mentioned, my previous role had me in the trenches quite a bit when it comes to control, answering support calls, providing field engineering support, and occasionally programming projects. So because of that, I'm very excited to be able to share with you what we've been working on in terms of control at QSC. So when speaking of QSC control, excuse me while I slide back, when speaking about Q-SYS control, we can best summarize it with these three key aspects of our platform. We want it to be integrated, we want it to be simplified, and we want it to be scalable. So let's start with talking about the integrated control aspects of this platform. With a traditional hardware-based control system, and when deploying a typical space, you're looking at usually having a control processor, possibly an audio processor, a couple of video cameras, some video distribution, and some form of a control point, either in the form of a touchscreen or keypad, and some amp and speakers. Now that alone is a lot of hardware to manage, but the real issues start to begin when you need to program it. That program integration can kind of look like this. The control programmer needs to come in and program every bit of that integration, making it so the control processor can talk to the audio processor. Then the audio processor needs to be able to report back to the control processor. The control surface needs to query the control processor to get button feedback, amplifier status, anything that needs to be presented to the user. And all of a sudden, this can be quite a mess to manage, leaving a large potential for error. And I personally have experienced the joy that is being asked, can't you just add this late in my programming process, completely derailing the work I've been doing earlier? That one signal taking you from a cleanly compiling program to 117 errors. Now, this is what it looks like in Q-SYS. All these devices report directly to the core via standard IT network, and all these pieces are native. And when we start to talk about third-party control, we have a robust plugin framework that has allowed deeper integration since version 4 of our software. This allows these devices to communicate in a more native fashion to our core processors. We have a growing number of partner manufacturers developing their own plugins for our platform, as well as our own internal development efforts. These plugin files can encapsulate control programming, the UI, and DSP processing as needed. Whether the device is native Q-SYS hardware or an integrated third-party element, these can help you save time, money, and save you some support headaches. So let's take a look at a quick example. So in this space, in this fictional space, on my touchscreen I have some source selection, some environmental controls, VoIP dialer, but for some reason I left out camera controls for my PTZ camera. And I've since realized the error of my ways. Now with Q-SYS, I can add that to the system without any additional programming. A little drag and drop, a quick push to the system, and I've added camera controls to my product. Once again, no programming required. Now that in mind, let's talk about simplified control. Every control platform is claiming simple operation for end users. One-touch control, intelligent spaces, and we understand and we can do all of that too. But when we talk about simple control, we don't just mean for end users. We mean simplified control for everyone, whether you're an AV programmer, an installer, or an IT professional. It's simple to install, it's simple to get in your infrastructure, and it's simple to support it. As Martin mentioned, our platform is built on IT-friendly standards, leveraging the power of Intel processors, the Linux operating system, and IEEE standards. This means it fits into your existing infrastructure. Once it's in, it's designed to be accessible. And similarly, when we were evaluating our control programming standards, we wanted to make sure they were equally friendly to all the stakeholders. As I mentioned earlier with that touchscreen example, our programming environment simplifies things by using a combination of drag and drop programming elements, further enhanced with the addition of a modern scripting language. There are no proprietary languages on our platform. Additionally, we wanted a system that was easy to monitor from anywhere. This is likely a familiar concept from an IT perspective, where you already have SNMP dashboards designed to help monitor and manage your IT assets and infrastructure, but generally this leaves out AV. Now, there are a growing number of other services that can cater to this issue, but none of them really seems to meet the demands of their customers. And we are taking this as an opportunity to do it better, providing a more native way to monitor and manage your AV assets like the rest of your systems. Now, lastly, let's talk about what we mean by scalable control. So to illustrate the scalability of our platform, I'm going to revisit my example from earlier about how things are typically done now. That traditional meeting room system design involves dedicated hardware. So here it is again, our control processor, our audio processor, a couple video cameras, touchscreen, and any other peripheral devices. Now, all of those devices are dedicated to just that space. And this might be good for one room, but it doesn't scale very well because all of that hardware is trapped in that one space. When we want to add an additional room, we're often left with exponentially adding hardware for each additional space. And when we start to add up all the pieces of hardware for these rooms, the cost of adoption and maintenance for all of these, all of a sudden, this is a lot of hardware living alone, mostly siloed in their individual spaces. It's easy to see how this can become costly, clunky, and overwhelming. And it simply does not offer the flexibility and scalability required for the modern enterprise. Now, this is what Q-SYS looks like in a meeting space, a truly scalable solution. You have a core processor that takes care of audio, video, and control. It can live in the room, it can live in an IDF, it can live in an MDF, or anywhere else. And it serves the room via pre-existing standard IT infrastructure. So when you are ready to add control to another space or another room, you can do so with just a software push. That's the power of Q-SYS. Now, rather than adding boxes on top of boxes of new hardware living on their own, making them difficult to manage and update, this platform scales. It's easier to install, it's cheaper to install, and it's exponentially easier to maintain. You get to avoid 3 16-hour days simply to update an entire building and no longer have to fear the Friday afternoon firmware update. And who doesn't want that? Now, when I say scalable, I also mean to any size. There we go. You can go from a small single meeting space all the way up to an enterprise-wide solution without ever facing a rip and replace scenario. Our smallest core runs the same software as our largest core. So let's say you started off with a handful of rooms, but later you decide to roll this out enterprise-wide. So as you add more spaces, you can simply add additional cores based on the size of your project. We have cores designed to handle a group of rooms, cores for an entire floor, or cores that can handle an entire building. And all this can be done while maintaining all of your programming and your endpoints. And I'm just going to say that again for repetition's sake. Programming can remain intact. Unlike some other platforms, when you use their programming light solution, these configurator-style programming solutions can hit ceilings or get exhausted. And you're left rebuilding from scratch when you need to add something more complex than that platform was designed for. And sometimes that complexity is nothing more than branding a user interface. And that simply does not happen within Q-SYS. And that's the beauty and the power of a software-based solution. So now that we have a good primer for the platform in general, I'll pass this back to Cynthia so she can intro our next speaker, who will give us a closer look at Q-SYS control in action.
Thanks, Greg. And yes, next up we're going to go into the real world, and we're going to hear from Brian Crist, who's going to talk about an installation at the Chicago Teachers Union and Foundation. And to this point of these multi-rooms, he had the charter to integrate the activities across 25 rooms. This was a major technical upgrade, included extension of video conferencing capabilities, implementation of a 40 gig fiber backbone, and then of course an installation of Q-SYS to give him comprehensive and unified control over the whole thing. Just a little background on Brian. He is definitely one of us, started in production, moved to integration. He's been in the Pro AV industry for 22 years. He currently works as the technical support and application specialist at Audio, where he assists dealers and end users with the design and implementation of cutting-edge solutions. I've seen this presentation, and I'm eager to turn it over to him. It's really interesting. Go ahead, Brian.
All right, thanks very much, Cynthia. There we go. So we're going to go over a installation at the Chicago Teachers Union, new headquarters in Chicago, Illinois. So this building was a renovated, old turn-of-the-century Doyle Valve Company building. And it's 110,000 square feet, or 10,000 square meters, and that in of itself posed some different issues. But we're going to focus on the audio and control related items for now. So the system was designed by Threshold Acoustics out of Chicago, and because of the size and scope of it, it presented a number of unique and common challenges that the Q-SYS platform proved to be a really good solution for. The primary focus of this entire project was ease of use for any employee or member. So not only did we have a building full of employees, both full and part-time, but also literally thousands of members and volunteers that would be using the various rooms in the building for different events, huddles, education, telethons, pretty much whatever you can possibly think of. The system also had to be able to control multiple types of third-party equipment across the entire building. You can see we have a few pictures there, but we'll get into this in a little bit more detail as we go through the presentation. The project was also very time sensitive. As the majority of people listening to this webinar know, AV and control usually gets left until last, and that was no exception here. So there are a number of things about Q-SYS that made it very, very easy to focus on specific areas, get those up and online, and get the system running in a timely fashion. So there are 27 spaces throughout the building. Those are primarily on 2 floors with 1 floor yet to be expanded on. And as you can see from the pictures on the next few slides, those spaces are greatly varied in size, use, and potential operators. Here we can see everything from a standard conference room, smaller one, a very large multi-purpose hall, down to smaller huddle spaces, educational spaces, and public spaces. And again, we really wanted anyone to be able to come in off the street and be able to operate this as if there was just purely magic behind it. So here you'll see a partial listing of some of the products that we put in. The installation was spread out over 3 floors, the basement first and third, and the locations and the specific QSE gear were chosen for maximum effectiveness, and again, the end result had to be a seamless user experience. The integrator that installed this system was Pentegra Systems out of Chicago, Illinois. So now we're going to get into the software a little bit and just show you a few things that really helped me along in the design process. So the first thing I'll discuss is pagination. And put simply, that allows you to put different things on different pages. And as you can see from the screenshot here, at 11 pages for the first floor alone. So not only did this allow me to keep my head straight while I was designing the system, it also really streamlines the process of commissioning the system. Instead of looking over a large aerial view where you can't really make out anything but just need to remember where things are, you can simply click on the appropriate page and go right to where you need to be. Along with pagination, we also have signal names. Now, the signal names are those little flyouts that you see sticking out from some of the blocks there. The nice thing about those flyouts is they can be used for both audio, video, and control. And they can go across pages, but behave just like a wire does. So you can have one output go to many inputs, the same way that you would normally wire a system up. UCI creation is extremely easy, and Gregg touched on this before. So for simple UCI screens, all you have to do is drag the control you want from the designer screen into the UCI Creation screen. There's a number of tools built into Q-SYS where you can change the shape, color, and icons on the buttons. And additionally, you can also import custom graphics to either act as buttons or as backgrounds. So what are we actually controlling with Q-SYS? So the thing we're controlling the most of is video streaming over IP. So in this particular building at the moment, there are 74 endpoints. It's another time to mention, as Martin said earlier, this is all coexisting on one network. So not only do we have the advantage of not having to jump back and forth, it also allowed us to consolidate everything in one single platform. So here you'll see in the upper left is a control button component that I will go over a little bit further shortly. To the right of that is some script that was written just to basically actuate radio button function for the different sources and change the media stream receiver, which you'll also see there. That allowed us to pull the audio streams directly off the LAN, which meant we could eliminate a lot of analog I/O. So not only the parts, but the labor that went into that as well. And at the bottom, you can see a 7-inch touch panel example screen with the video where you could select from different sources or go to a favorite TV channel. We also controlled some pan-tilt zoom cameras that were not QSC, although we have a QSC PTZ in there as well. Here you'll see we're using command buttons as well with a little bit of script to add some nice functionality to the pan, tilt, and zoom buttons and control a bit of the presets as well. So we also used Global Cache's IR over IP control. And what I really wanted to show you on this slide was that there's many ways to do control inside of Q-SYS. So in the bottom right-hand corner, you'll see a way that just uses a scriptable control block to make the buttons radio buttons, so only one can be on at a time. And those are going through various control delays, and those control delays then go to push the buttons in a command button line. And that's how we got the favorites to operate. Since then, we've taken all that and packaged it using scripting into a nice 2-screen cable box control that you see here as well, where you can simply enter in the commands, enter in your favorites, and then drag the controls right into your UCI and create something in a matter of minutes. We also had to control a number of different display technologies. Here you'll see a nice view of the command button block. So utilizing this, you simply need to know the IP address of the device you're controlling, then look up the port number and the commands inside of the manual, type them in, and it's a single button push to control the device. You'll see some hex commands on either side. Those were just simply necessary because we were actually passing the RS-232 through the video streaming endpoints. We also were controlling a Roland M300 mixer for the large meeting space. Here you'll just see some code examples. We kept this one really simple because when they want more control, they simply switch over to the Roland M300 app. And the system is ready and waiting to go for future enhancements. 2 of them are going to be integration of a Cisco SX20 and a VoIP service for the conference room. You can see there's some scripting examples there on the left for the SX20. And in the center, you'll see how we took the dialer built into Q-SYS for VoIP and kind of dragged it out, arranged some icons and things, and really tried to make it mimic a smartphone screen, which most people are very familiar with. So what was the end result of this entire installation? Well, there's been an extraordinarily low volume of support calls to myself, the integrator, and the internal support staff at CTU, which has obviously made everyone very happy. The system has already been expanded twice, and at the advent of getting that second floor finished and occupied, we're looking very much forward to expanding it more. So with that, I'll thank you for your attention and throw it back to Cynthia.
Thanks, Brian. It's great. So our next speaker, actually our next 2 guests, are both from Atero Tech. We're going to be hearing from Chris Lord, who's the product engineer. to get a little idea about how this works with partners. So Chris Lloyd joined Aterotech in 2007 and has been a master of technical support for more than a decade to Aterotech's network audio product customers. In early this year, Aterotech began developing control plugins for Q-SYS Designer for Dante and AES 67 enabled products, so for both those codecs. Chris has been the primary developer for all these plugin development efforts to date. So when he isn't providing technical support and writing control software, he does his part fighting rebel scum while raising money for various charities as an Imperial Stormtrooper with the 501st Legion, and I think that's a real thing. So I'm going to turn it over to Chris Lloyd. He will be backed up by Josh Arnold, who I'll introduce when we go into the questions. He'll be around for question answers. Okay, Chris, go for it.
Thanks, Cynthia. Thank you very much for that introduction. I've forgotten I put the 501st stuff in there. But anyway, for those of you who are unfamiliar with Aterotech, we're a company based out of sunny Fort Wayne, although the weather is anything but sunny today, here in Indiana. For the past decade, we've brought innovative networked audio endpoint connectivity solutions to the Pro AV market. Utilizing various audio networking protocols such as CobraNet, Dante, and now AES67, our product range from small wall plate style audio endpoints to high channel density rack mount audio interfaces, covering virtually all application requirements for Pro AV audio connectivity. As an endpoint manufacturer, we recognize that a critical key to our success lies in seamless integration into comprehensive AV system solutions. To complete the system solution, adequate integrator and end user control of our products has at times been elusive and quite frankly expensive, requiring control systems, hardware and customized programming to be paired with the AV system to deliver the complete package. So how do we go about controlling our devices? Take one of our wall plates, for example. What if you need the audio system to activate phantom power or switch an input from a line input to using a microphone on the fly? The traditional system typically had a setup that includes a DSP to deal with the audio processing, and a separate control system that allows real-time control of what the system is doing and how it's configured. There's a further complication to this. Most of our products only have a single Ethernet port and are thus expecting to have a combined control and audio network. Direct control of our devices from a separate control network by the control system therefore becomes difficult to accomplish. But what if we could simplify this? What if we could do so using a familiar architecture? The result would be less hoops to jump through and very little in additional programming required for the integrator. To put it simply, the QSC cores DSPs provide the platform to allow us to get around some, if not all, of these problems, and our key responses to these control issues was to develop plugins for our products for the Q-SYS platform. With seamless product integration through our Q-SYS Designer product plugins, we've been able to potentially eliminate costly additional control hardware, network infrastructure, and the hours of custom programming that may also be required. You know you have a winning solution if you can effectively do more with less. This approach to control and system integration, we feel, is exactly that. So by developing our own product control plugins for the QSC platform, we not only address our improved system solution, but we also provide our integrators and end users with some additional benefits. First off, seamless integration. We now have the control and flexibility to tailor the integration of our products to meet the demands of our integrators and end users who use Q-SYS as their primary AVC platform. We also have improved support capabilities. By developing our own solutions inside the Q-SYS platform, we have a greater ability to directly support our customers as they encounter issues in the field and react to quicker to their needs. And lastly, there is faster time to market. As a connectivity endpoint product manufacturer, we inevitably have a large number of products. The ability to provide plugins for the Q-SYS platform improves our time to market for a fully integrated system solution. Contrast this process with other manufacturers which also support our products in their systems. The use of Q-SYS plugins bypasses the logistical barriers, as we can now devote our own development resources to tackle the problem and not have to wait on our partner manufacturers to adopt our products within their specific environment. In addition to these important motivating factors, there was another primary motivator in Aterotech's decision to dive into Q-SYS Designer and develop our own device plugins. We identified Q-SYS as the only platform that gives us everything our clients and end users required for a comprehensive end-to-end system solution, and gave us the ability to answer a simple question about product control that often had no simple answer. Ultimately, all of these benefits adds up to enhanced value for our customers and a key differentiator for our own products. So what are these plugins? What do they look like? What do they do? The one shown here is for our recently released AES67 products, the UNA 6IO BT. When we designed the products, we had several design goals. The first goal is simple system commissioning. The plugins all have a common connection setup. That includes built-in device discovery, so there's no need to memorize device IP addresses or MAC addresses. The second goal was commonality, both between the devices and also between groups of devices. That gives us a common look and feel across all the plugins. Some features are also common to groups of products. Our AES67 products are a good example, where they have common AES67 setup features, as you can see on the right-hand side. The use of common features and functions across our devices is helpful to both us and the end user during development. It aids the user as a common setup means you learn it once, and it's the same across the entire range of Atero plugins. But from a development standpoint, the commonality means a faster development process and quicker time to market, particularly when creating plugins for new devices, as we can use code blocks that have already been tried and tested with other products. The third of our goal was to support product-specific features. Each plugin that we have developed has a specific set of controls tailored to control and/or monitor all aspects of that specific type of device. And lastly, the plugins were designed for system integration. The plugins can be used in different ways. If the end user never changes the setup of a particular device, so if your device always has phantom power on and set to line mode, then you can simply use the plugin as a single plugin, connect it to each device in turn, set up that particular device, save the defaults, and you're done. Alternatively, if you require on-the-fly control, so you need to change phantom power and gain and such like on the fly, then you can use multiple plugins, multiple instances, one plugin for each device, and control those as you go. And lastly, and most importantly, any element of all the plugins that you can see on the screen can be seamlessly added and dragged and dropped to a customized UCI within the QSYS framework. So here's some of the devices that we've developed for plugins for, all of which have been done since probably about March this year. The breadth of this product hopefully gives you an idea of the scope of the work involved. Most of our Dante products, a lot of our Dante products are already supported. The DX2IO, the 3IO, the 6IO BT, and the 6IO, they're all of our wall plate devices. There's also the 2x2 Plus, which is one of our flange products. Very recently, within the last couple of weeks, in fact, we've also then released the support for our AES67 devices, the 6IO, the 6IO BT, the 2IO, and the X4i. Again, they're the wall plate devices. There's also the flange product, the little 2x2 Plus. And there's more yet in the works as we move forward. Indeed, we have new products and updates to existing products not included in the Q-SYS designer. There will be any of those will be made available on our website. Those that are released will also be given directly to QSC, and they will include them in their next release of the QSC designer software. We plan to have the majority of Aterotech products supported with their own plugins by the end of 2017. If you can't find the plugin you need for a particular product that you're using, contact us. We already have one already available, and we may be able to supply it to you for testing. Finally, we continue to hone and improve the plugins as we go. If anyone has any requirements for additional features for the plugins, or indeed a unique case that the plugin doesn't cover, let us know and we'll see what we can do for you. And with that, that's all I have to say, so I'm going to hand back to Cynthia.
Thanks very much, Chris. So I'll just briefly remind you of a couple things. This is available on demand at this same link, and feel free to share it. We're going to now take as many questions as we can. There are a lot of people on the line, and there are a lot of questions, so we'll get to as many as we can. Patrick Hain, Director of Marketing at USC, is going to be fielding them, and let me just remind you that your panelists are Martin Barber, Product Manager of QSC, Gregg Matson, Application Engineer, Brian Crist, who is the integrator of the Chicago Teachers Union and Foundation, and Chris Lord and Josh Arnold from Aterotech. Patrick, I guess dig in.
Thank you, Cynthia. So I saw a lot of questions about cameras. not only our camera, but third-party control cameras. So the first question is for Martin and Greg. Can Q-SYS be integrated with third-party control cameras?
That's a good question, and we should probably start off by defining what we mean by integrate with. Integration, if we're talking about simple control, absolutely. As Brian described in his system design example, you can implement control of any third-party product or camera from Q-SYS, provided they have a freely available API. And when it comes to video integration with Q-SYS, then the story is somewhat different. One of the benefits of the Q-SYS platform is the very, very tight integration that we provide with all the Q-SYS endpoints. And that comes back to my very first slide. We're trying to make it simple and easy for you to build these end-to-end solutions. And we do that by developing all of our products from the ground up, designed to work together. So the Q-SYS cameras are very tightly integrated with the Q-SYS platform. The Q-SYS core manages their firmware automatically and manages their device discovery, their control integration. Everything about that Q-SYS camera is native in the platform. If you start to think about trying to integrate third-party products, then all of those benefits start to fade away. So at this point in time, we do not support video ingest from any third-party camera. But what I would say is that if there are room types that you are working on where the Q-SYS camera is not appropriate, then we would welcome that input, because we see that as an opportunity to expand the camera offerings that we offer with the platform.
Great question. A little bit of a follow-up question. A lot of discussion about the cores and how to choose your core for a given system. So what are the criteria that an integrator should use when choosing a core for a given installation?
Well, that really comes down to what it is you're trying to do with the project. We have three categories of core processors. We have the unified core series, of which with the core 110 is the primary core. That is got a fixed amount of onboard analog, audio, and control I/O, typically tailored towards single room applications, but can be used for multiple spaces. You imagine a small meeting room with a small number of peripheral huddle rooms. The core 110 is very appropriate for that. The core 510 or our integrated core series, that is offers the opportunity to implement any combination of our Q-SYS audio I/O cards. That includes all of the analog audio I/O, the data port cards for integration with QSC data port enabled amplifiers, the AES EBU cards, and all of our network bridge cards. So if your project requires interaction or integration with a vast range of different audio sources, then the integrated core platform is very appropriate. And then moving up to the enterprise cores, the new Core 5200 is really focused on centralized deployments, whereby you put your core processor in the data center and leverage the site-wide converged IT network to distribute audio-video control between the data center and the Q-SYS I/O endpoints throughout the facility. So really the question about the core choice comes down to the type of project you're trying to accommodate.
That's a great question. I think we answered a lot of the questions related to using other touchscreen devices, but can Martin or Greg, can you speak to the ability to put a UCI on something other than our touch panels, for example, an Apple, an iOS device?
Yeah, that's another great question. So in addition to all the native QSC touch panel displays, we also offer a Windows PC based viewer application which can be installed on any PC or Windows application. In fact, it can be running on a Mac as under a virtual Windows environment. So that allows you to use any computer as a control interface. And we also offer an iOS application for free download from the Apple App Store. We're also quite a long way through development on HTML5. So at that point, you will then be able to use any web browser as your control interface on any device that you want.
That's a great question. Now this is to Aterotech. Can you speak to basically supporting the plugin? There were a couple questions about who supports the plugins, and I believe that the answer is if it's created by QSE, QSE is going to support it, and then if the third-party manufacturer develops it, it's going to be supported by the third party. But if you guys can speak to that a little bit.
Yeah, you basically hit it on the head there, Patrick. For the public plugins that we've certainly developed, it would certainly be a case that any issues or queries about them would be directed directly to us, specifically me. Actually, I'm be the one who's dealing with it. If it's other manufacturers, then you'd need to go to them. But QSC do develop their own plugins too. So it really depends on what specific plugin you're actually using. So yeah, basically, whoever manufactures it is the person you need to go back to.
Perfect. A question just popped up. It's a little bit of preview to what we're going to be releasing shortly, but there was a question about if you can get QSYS scripts on GitHub. Martin, can you give them a little preview of what's coming?
The answer is not now, but it's definitely a technology that we're looking at using to provide easier distribution of QSYS plugins in the future. At the moment, all plugins that we support are shipped with the QSYS Designer software, which makes it very easy for us to manage. But of course, if you want to get updates, for example, from a TerraTech, and don't want to have to wait for the next QSYS Designer release, then there are challenges. So yes, GitHub integration and other such platforms is something that we're looking very closely at. That's a great question. Thanks.
Perfect. A little bit of questions about using centralized processors for control in regard to redundancy. So there were a couple questions about, what happens if I do this and that room goes down? Do I lose all of these rooms? Martin, can you speak a little bit about QSYS's ability to give a redundancy option to those who want to invoke that?
Absolutely, and that's another great and very important discussion on this whole topic. Redundancy has been a key founding bedrock of the QSYS platform from day one. From an audio perspective, from a networking perspective, and from a processing perspective, the QSYS system has always offered full redundancy since we came to market in 2009. So if you're doing a solution leveraging QSYS audio processing and control from multiple spaces, and you're doing that using a single core, the customer has the choice. If you need to provide redundancy, then you would add a duplicate core processor onto your network. That needs to be the same model as your primary core, with any of the same accessories, for example, multi-track players or media drives, etc. But they can be located anywhere on the network infrastructure. So typically you would put them in different IDF rooms or data center rooms. Once you've got those two cores on your system, actually it's a single click operation to make your system behave as a redundant system. And what happens is your design file gets pushed to both cores. One of the cores will be active, doing all the audio and control processing in real time. The other core will be in a standby state, and it will be in real time mirroring all the control value changes on the active core. And it does so that if it needs to become active, it's already in the exact same state as the primary core was. So in that configuration, you have two cores. One is active, one is in standby state. It's in a mirrored state. If the active core is taken off the network, the backup core will take over automatically. And that switchover requires that all the peripheral devices resynchronize with the primary core. That takes some amount of time. It's typically in the order of between 5 and 10 seconds for a complete system changeover from an active core to a backup core. But it is fully automated. The customer doesn't have to do anything.
Perfect. Thank you, Martin. A couple of questions about Core 110 and specifically. We're talking a lot about video, and if you could clarify, Martin, the use or the lack thereof of that HDMI port on the back of the Core 110.
Yeah, another prize for eagle eyes. So those of you familiar with the Core 110 will recognize that on the back it has a HDMI connector. Those of you who are somewhat familiar with QSYS and this presentation now will also understand that the core is effectively a PC. And as a result, we use standard motherboards and Intel chipsets. It just so happens that on the motherboard that we are using on the Core 110F, it has a built-in HDMI port, and it would have been more timely and costly to remove the HDMI port. So in fact, we use it during development for debug, but it does not currently feature as a user accessible function at this point in time. Now, that could change in the future, but at this point, there are no immediate plans to enable that for customer use.
Great. This question is for Gregg, actually. What are the scripting languages that Q-SYS supports? A lot of questions about that.
So currently, the scripting language that we use is Lua. Lua is a lightweight but very powerful embedded scripting language, which kind of and that lightweight and the power that it has is part of the reason why it's the only one we have integrated right now. We are currently discussing the possibility of adding other language support in the future. But if you're familiar with Python or JavaScript, Lua is actually pretty similar in those. It doesn't quite have the breadth of libraries that some of these others do, but it's also a whole lot more usable from an embedded language standpoint, which is why we have leveraged it ourselves. Additionally, we have some other. Well, personally, I found Lua to be pretty easy to pick up, but we have some other tools that are coming in the next few months that should help with lowering any potential barrier of entry anyone sees if you've not heard of Lua prior to this conversation.
Perfect. Thanks, Gregg. This question is for Martin, actually. Can you speak to using Q-SYS on existing IT infrastructure? Can it be used in parallel? Can it exist on that network?
Absolutely, and that's another really important question when considering this platform. Q-SYS was designed from the ground up, built using IT standards to allow integration with any modern and standard IT network. So, but at the same time, it is also network agnostic, and by that it means Q-SYS doesn't care whether it's an isolated, dedicated network or it's converged with your IT services across your building. All that Q-SYS requires is appropriate quality of service on that network infrastructure. So yes, Q-SYS can be deployed, and in fact we have hundreds of examples out there in the wild on project sites right now where Q-SYS is working and behaving very well on the converged site-wide system network. And in fact, because of this, because of the way the system is being developed, we're able to provide completely deterministic audio input to audio output system latency. In fact, any analog input to any analog output across the platform can be accommodated in just 3.167 milliseconds from analog in to analog out. That includes A to D conversions, network transport, signal processing, and of course back out across the network. So yes, fixed signal latency on a completely standard IT network is what the platform is built on.
Just to let everybody know, there's tons of questions, and clearly we're not going to get to all of them. We're going to get to 2 more, I think, but all of these questions are being captured, and we're going to get to answer all of them. So keep them coming. Even though we're going to run out of time, we're going to answer each and every one. This next one is for actually a Terratech. Can you speak to the difference between your AES67 devices and your Dante devices and the way that those interact in the plugin?
The plugins themselves are actually very similar. Chris kind of alluded to some of the capabilities of the AES67 plugins in his presentation, but our AES67 products are basically our own implementation of AES67, so we are not using Audinate hardware for those products. So that's the main difference in the two. But again, the plugins for each of the products represent the same product features and the similar control capabilities, and actually a very similar proprietary control protocol under the hood. So functionally, there's not a whole lot of difference. It's just all about the compatibility options that you prefer, whether you're using a Q-SYS system that is Dante enabled with a card, or if you're using a DSP like the Core 110 that natively supports AES67, then you can now use our products along with those systems.
Perfect. And we're going to end on this last question. There were multiple questions about using, if you have devices that are not IP based, for example, RS-232 devices, what is Q-SYS's solution to that? I'll throw that over to Martin.
That's great. Again, so IP control is very straightforward, and when it comes to devices that need physical connectivity, then the vast majority of our devices, whether they be the core processors themselves or the I/O endpoints, feature some amount of control I/O in the form of GPIO, in addition to RS-232. So that accommodates many requirements. It clearly doesn't accommodate all requirements. And so for situations where you need perhaps 422 or 485 or multiples of those, then integration with third-party solutions through things like global cache actually work very well. So we have control scripts that are available today if you contact QSC that allows you to integrate global cache products with Q-SYS, and in fact we're working very hard on turning those into official plugins. So that is how we accommodate that integration.
Perfect. That's going to be the last question. Go ahead and wrap us up for us, Cynthia, please.
Okay, thanks everyone for attending. I'll remind you to go to the on-demand, and we'll see you at the next one. Thanks, you guys.